Homie, what's that? Look, look, what's that? Oh, there. Hello. Come on.
How you going, guys? Curtis from Cutting Edge Engineering. Today's job, we're going to be working on the extension cylinder out of the boom from the Franna Crane. So as far as we know, this cylinder doesn't have any damage. It wasn't leaking. It wasn't having any trouble cycling. It was doing everything correctly. But because of how far I'm going with this project, I really want to make sure this is 100%. So today we're going to disassemble it, do an inspection on it, and hopefully we just have to do a reseal. And because this cylinder is so long, in its current closed position, it is over 5 meters in length. And when it is fully extended, it is going to be nearly double that. So what I've done is I've set it up on the bed of our green milling machine, and I will then use the crane that was originally used for lifting aircraft from one side of the shed over to the other side. We can use that because it is in perfect alignment with the bed of this mill. So the first thing we need to do is crack the gland so we can then remove the rod. As you can see, this cylinder looks different to a lot of the cylinders that we would work on for a dozer or an excavator. Instead of the rod eye being a round eye that a pin goes through or a trunnion ball, this has got a block on it. And that block is used to then anchor the cylinder rod into the boom. This is also configured differently. There aren't any oil ports on the barrel to feed oil into it to cycle the cylinder. The oil ports are on the block, and then that feeds oil into the cylinder to cycle it. So what this means is the rod is going to be hollow. We are going to find holes drilled or something like that at the end of the rod just in front of the piston to allow oil through for the cylinder to cycle. See how far we need to start to spin. So the barrel is spinning when I try to undo it. I'm not going to try and clamp it down anymore because I could deform the barrel. So rather than risk deforming the barrel with a strap clamp, I'm just going to put a piece of pipe through the end of the cylinder and I will lock it against the little lathe so then it doesn't want to turn anymore. So we did manage to get the rod to move a little bit, but we did end up finding a few lines through the chrome work, so it'll be interesting to see what exactly caused that, or whether they're going to be a massive problem for what this is used for. And I have tried to get the gland to move by using a filter strap, hoping I could make it spin. Unfortunately, it is far too tight and I can't get behind it in order to hit it out because the gland is hard up against the end of the barrel. So what I think I'm going to have to do, I'm going to have to extend the rod all the way out until the piston bottoms out against the gland, and then I should be able to give it a few taps with a hammer and get it to come out of the barrel. Acts like a little hood. Oil will hit it and fall in. Near the buff end, that should be right. No rust pits. Alright, we'll keep strapping along. Hood works.
Yeah, the hook does work. Good job.
Still another 1.5 metres of rod in the barrel. Thereabouts.
You run out of room.
Yeah.
Or is that it?
One more. Kidding. Yep, it's coming. Why?
Yeah, slowly. Righto guys, so after a bit of a struggle, I did manage to get the rod free of the barrel. It seemed to be quite tight the whole way down, and it makes sense now that I can see what seal group is being put on the piston. They are renowned for being very tight, but they are extremely robust and they will put up with a lot of punishment. And because of the length of the cylinder and the rod, if I have a slight misalignment between the area I'm pulling from to where the barrel is, that can also fight me. I did make a few adjustments as I was going through. It didn't seem to get any easier. I'll put it down to the seal group, which is extremely tight. So now what I'm going to do, I'm going to take the rod over to the press, clamp down on top of the block, and then I can remove the nut, the piston, and the gland. Oh, there it goes.
So the nut came off without any dramas at all. This is actually a two-piece piston, which means it can be assembled very easily. The seal group are quite robust, they are very heavy duty, and there is no way you're going to stretch those over the top of a one-piece piston. So because it's made in a two-piece, you can put a much heavier seal group on there and it's easier to assemble. Stop tube. So what this is a limit tube, also known as a stop tube, and it stops the cylinder from fully cycling. Because of its length, if this was to be cycled without the stop tube in it, you could end up bending the barrel or deforming the rod. There does need to be a little bit of support in between both of them, so by limiting its stroke, it adds that little bit of support that it needs. And as you can see on the end, they actually have put a bit of a weld there, and that's actually to stop the tube from going up the chrome rod when it is cycling.
Okay, now that the rod's been disassembled, we can now remove all the seals out of the gland.
Difficult.
So that's all the seals removed out of the gland. Everything came out nice and easy. So while we're ordering the new seals for the cylinder, we're also going to replace the seals on the check valves because they were a little bit damaged from where someone had actually put them in and just caught the corner of one of the O-rings. Considering the condition of everything else on the rest of the crane, these seals are in very good condition, apart from a bit of wear in the working areas on the seals, which you would find regardless how old they are. These are in really good shape. You could probably use these again, but considering how difficult it is to get this cylinder out, I'm just going to replace the whole lot. So the good news, the piston, the gland and the rod are in really good condition. I'm not going to need to replace anything. There are a few little marks in the chrome that I might just buff down, but all in all, everything's in pretty good shape. And I've got no concerns that there's anything wrong with the barrel because the seals that we took off the piston are perfect. There's no damage on them. They aren't scored in any way, shape or form. So that tells me the barrel is going to be okay. But when it's reassembled, I am going to sandblast the entire barrel and repaint everything. And one of the bonuses of having my older brother Troy here, I've ordered the seals and he is now gone to pick them up, which means we can continue on with the rest of the cylinder and getting the rod ready. So I've gone ahead and cleaned up the gland nut and the gland. I've just used a wire wheel and some brake cleaner to remove any debris. And we've given the piston a quick clean as well. So if you're wondering what those marks are that go around the rod, I've worked it out. I guarantee they are from the nut that holds the gland in, bouncing on the rod when someone has been installing the rod into the barrel. They may have had to hammer it in, and they look to be impacts from the nut bouncing down the rod. So I am just going to buff those out. What I used was a very blunt 120 grit abrasive belt. Because the seal group that is being used in this cylinder is so heavy duty, that sort of stuff is not going to bother it at all. And I've also gone ahead and cleaned the entire rod with brake cleaner, and that's come up very nice. And now our new seals have arrived, so let's get them installed. To replace all the seals, it only cost $180. So for the piston, we've got 2 wear bands and the pressure seal. So on the outside of the gland, where the gland seals to the barrel, we have a backup ring and an O-ring. On the inside of the gland, we have 2 wear bands. Above that, there is a U-cup seal, which is the pressure seal. And the U-cup seal also has a backup ring. And above that, there is the wiper seal, which seals all debris from going down inside the cylinder. The gland nut's pretty simple, it's only got an O-ring in it. And for our check valves, we have 4 backup rings and 3 O-rings on each. Something that might catch people out is the backup rings actually have a radius in them, and that is to suit the O-ring, so they do need to face the correct way. And the last thing is an O-ring that goes on the rod and is underneath the piston.
So as you can see, there are holes in the end of the rod in order to cycle the cylinder. We have one hole that comes out on the top of the piston that is used to retract the cylinder, and another hole comes right through the end of the rod that is used to extend the cylinder, and they are both fed from the main block where the hydraulic hoses are connected. Now we got all that fitted back to the rod, we're ready to reassemble the cylinder, so let's get the rod back in the barrel. And to give myself the best chance of getting the piston in the barrel, I am going to be using my magnetic level. I'm going to take a level off the barrel and then I will make the rod the same level so everything goes in nice and easy.
Righto guys, so the rod went in far easier than it came out. What I need to do next is fit the check valves, then I can get this prepped, ready for sandblasting and painting.
Oh, you bastard.
Jesus!
Typically this is not the style of puller that I would use for removing this pulley because they are a bit of a nightmare to set up, and I'm not really pulling off the strongest points of the pulley. Because it's lifting up from two legs and it's on the outside of the wheel, there's not a great deal of support. It is actually gonna flex it as it tries to pull it up. I would generally use a bar puller. You would use the two threaded holes in it to go down through the puller, and then you would wind it down to then extract it. My brother's actually borrowing that, so we're just gonna make do with what we've got. So that's just not working. I'm going to quickly machine up a centering plug to give that puller the best chance to work. Pull that off the bearing. Righto, the plot thickens. So that didn't really go to plan. All it did was pull the pulley off the bearing, and unfortunately I can't get my bearing knives underneath that bearing in order to get enough purchase to lift it off, and the pullers just don't reach under there either. So I think the best course of action will be to cut that bearing off, but I'm going to turn it over and try and remove the other pulley. Righto, so that pulley's done the same thing, it left the bearing behind, so I'm just going to have to cut them off, but I still need to remove the bottom roller and the wear pads. Cap from the other side. Brass screws. It's worn right down. Oh, no, we got it. So now they're off, we can take it outside and get it set up for sandblasting.
Righto, so we're going to be using our new RapidBlast system. If you want to see how we set that up and used it for the first time, we'll leave a link in the description below. So that sandblaster only took about 15 minutes to take all that paint and rust material off this cylinder, so very happy with how quick that has made that part of our job. So now we're going to get this set up ready for paint. Righto guys, so that's our boom extension cylinder painted. Really happy with how it looks. I put this in my top 2 of paint jobs I've ever done, and I put that down to being able to prep the surface correctly with a sandblaster and everything being nice and clean. So that's this job pretty much completed. I still need to fit new bearings and pulleys and the wear pads, but the cylinder's far too wet to do that today. So we're just going to leave this to dry. And I was hoping to get onto the boom and remove the pulleys and all the wear pads off that, but because of the trouble I had removing the pulleys off the cylinder, I'm going to order in a new bearing puller so they're far easier to take off. So you'll see that in the next part of the Franna Crane project. Thanks for watching. Righto, so
Hang on, you've got black stuff on your nose.
help me out. I can't see.
Now you look crazy.
Cylinder rod. Are you ready?
Yep.
How you going guys? Curtis from Cutting Edge Engineering. Today's job we're going to be oh wait, what'd you say? How you going guys? Curtis from Cutting Edge Engineering. Today's job, oh wait, was that it right? Today's
Yes.
job, right. How you going guys? Curtis from Cutting Edge Engineering. Today's job we're going to be,
Working on.
How you going guys? Curtis from Cutting Edge Engineering. Today's job we're going to be, oh fuck me.
Do we need to do this word by word?
I think we do. How am I starting it? So righto, or righty?
Righto.
Right, right, you ready?
Yep.
And, oh wait.
Don't get into don't get
cylinders.
into how it's configured just yet.
Right,
What it looks like.
right. So this cylinder is configured,
Oh my god.
right, so as you can see, this cylinder is configured very different. Oh, what?
You said configured again.
And this is also, oh fuck, hang on. Oh fuck, what? Oh fuck, how do I say it? Oh fuck, I've tried.
What's the point of the bag?
So I don't spurt it everywhere. So I'll zip tie the bag to this. Acts like a little hood. Oil will hit it and fall in.
Cutting edge stuff right here, guys. I tell you like that's the best hack ever.
I'm not going to get wet.
Prevent spillage.
Prevent spurtage.
Is that a word? No, that's part of Kurdish.
Curtis English.
Typically this is not the style of puller I would use for pulling off this sort of pulley. This, oh, fuck me, there's too many pulleys. Righto guys, so that's our boom extension cylinder completely painted. Duh.
Hey.
Double fuck.
Curtis is looking for something, guys. Let's see who finds it first.
Big shifter. It's down here. I knew it was there. That was exactly 63 ooga-doogas.
Were you counting?
Yep. Now we get to put this motherfucker back in the barrel.
It's muddy. He's all wet.
You're wet. Oh, yeah. Who that? Who's that? Over there. What you getting?
Yeah.